So thank you, Francesco. It's a pleasure to be here with you and also your knowledge.
Okay. Hope that you can see now the slide. Thank you very much for this opportunity to participate in this event. It will be a very difficult task in 20 minutes to touch all these open issues that you have mentioned also in your replies. But let's try to do that. So my goal is essentially in this presentation to focus a bit more on the models that artificial intelligence and in particular machine learning is using nowadays to try to give you some tools in order to generate new ideas, because just showing the examples could be, let's say, misleading. You can imagine that this could be done or other things have been done, but could be maybe difficult to be done. But if you think about the real model, the abstract model that the technology is using, then you can probably generate some new ideas. But let's make a jump into the past. Let's go back 70 years in the past. And I have to start my presentation with mentioning the Turing Test. That probably many of you have heard about that. But this was, the basic question was, what is intelligence? What is this intelligence that humans have and machines don't have? And so Turing thought about this simple test where there is a person that is interacting with other two, let's say, agents that they are behind the wall, can only interact with the monitor, with this interaction. And the goal is essentially to understand who is the machine and who is the real person. Now, this is a complex task that actually, even now, we are not even able to build machines that are able to completely pass this Turing test. But apparently, we are able to do something that is quite surprisingly difficult. So, for instance, this is just one example that I took from the press, very recent. So AI beats human in selfie personality test. So artificial intelligence can analyze images of selfies, and from these images understand what are your personality traits. So if you are an extrovert or you're not an extrovert. No? And this is because using this technology, they can better than us recognize some hidden features in the images that will signal the presence of a particular personality. So for this type of task, machines are even better than humans nowadays. And there are many other applications that are interesting because the machines have acquired a level of performance that are impossible for humans. So think about this first example. From eScanner can tell if you are mastering a foreign language. This is something obviously that we are not able to do. Now, the other example, big data tool predict the best lung cancer treatment. Yes, we have physicians that are able to do that, but a physician cannot exploit maybe examples, millions of examples and hundreds of possible treatments and really try finding the best treatment by using all this knowledge. You know? So machines can really leverage this knowledge if this knowledge is available. Now, how this is possible? Now, there are here other two examples. I will not spend too much time in negotiating all these examples. I want to make, let's say, a very, very simple example to explain to you how this is possible. So let's go back to a children, and the children has to learn the flags of Europe. No? So has to learn that this is the flag of Italy, or that one is the flag of Ireland, or that one is the flag of Switzerland. How this is possible? So there are some computational models that are called neural networks, where there are nodes that are computational entities, and these nodes are connected with the other nodes through edges. Nodes are organized in layers like this one, from this first layer, which is the input layer, up to the end of this network, which is the output layer. So what we have to do in order to build, let's say, a machine learning model that will recognize the images of flags, we have to offer to the network some images like this one, enter these images into the network, which means that for each pixel of this image, we have to, let's say, connect this pixel to a particular node of the input layer. and then make a computation and see what is happening after this computation. So imagine now that in the output layer, each single node represents a country. So the first one will represent Italy. So we want that when we present flags of Italy, this node will, let's say, 5 will be 1, and the other will be 0. No? In order to make this feasible, we have to train the model. And training means offering to the model a lot of examples and telling what is the right output and correcting the computation which is performed inside the network in order to get the right output. So when you do this for many, many examples, for each flag, you have to present many images because images can be different. The colors could not be the same. Let's say the angle of that was used to take the picture was not the same. So when you are showing a lot of them, let's say slowly the network will tend to produce the right input when you present even a novel image of a flag. Okay, that's the basic idea. And obviously this idea has some important advantages. They are very, very simple ideas, but I think that we have to reflect on these very basic ideas. A computer does not forget. So when the computer has learned that, will not forget, while we forget a lot. No? And computers can actually solve problems with a lot of flags. So a lot of cases can be analyzed, and in fact, a lot of information can be used in order to train the model. So these are obviously very, very positive aspects of our computational models. But there are also some problems, some difficulties, something that some disadvantages of these models. So first of all, the first is a big disadvantage that sometimes we don't recognize that, is that even for a very simple recognition like the flag of Italy, it doesn't suffer to have one single image. We have to present to the network many images of the flag of Italy. While our children at primary school, they don't need this. They just see one flag of Italy and they can recognize all the other flags. Because we have a structure that is already in some sense, let's say, pre-trained, that can help to learn. And this is in fact one of the major problems also of the research nowadays. So if you have a novel problem, which is not exactly the problem that you saw before, so for instance, the flags of Asia, you have learned the flags of Europe and you want to learn the flags of Asia, you have to train again, and you cannot really exploit too much what you have learned. So there are now technologies that are called transfer learning, where we try to use partially train the models in order to learn problems that are different, but that's quite difficult. So what I would say that we think that, for instance, learning Latin will help you to learn mathematics, but this is not the case on a computer. One has learned Latin, has not learned anything about mathematics. They are completely different stories. And then there is also another issue that we have to really understand, that behind this magic, there is always a person. There is a person that has built a particular structure of this model, this cluster third point. And with this particular structure, the model can really learn, can fit the problem that is now considered. Another problem requires another structure. We do not have these very general learning approaches that can learn whatever we are presenting and adapting automatically the full structure of the model. Now, these are things that we are able to do, and we are able to do even some more, let's say, peculiar things that I'm sure some of you have already seen. We can create fake videos now, so like this one.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time. Jordan?
Okay, so this is Obama. Now we think that this is Obama, but actually this is not Obama. This is a Muppet that is moved by this person, because you see...
Peel created this fake video of President Obama to demonstrate how easy it is to put words in someone else's mouth.
Moving forward, we need to be more vigilant with what we trust from the internet.
So it's possible to create videos of people that maybe celebrity, maybe important people, and let them tell whatever we want. No? This has obviously some recent problems. Also, there are also maybe some potential good application, but there are also a lot of let's say worrying applications. And this is again something which is done by using, let's say, machine learning models. Now, it's interesting that here we have two models. In this case, these are called generative adversarial networks. So we have a network which is generating examples, and we have a network which is called the discriminator, which is just telling to the generator whether he is making, let's say, progress towards the solution of a problem or not. So in this case, you see that it's trying to generate a picture of a cat, and the discriminator is, no, this is not the cat. Then the generator is improving, making a better picture of the cat, but still is not very good. And the discriminator say, no, you have to correct this. And finally, he's able to generate a good picture of a cat. So these two networks together are two artificial intelligence, in some sense, models that are combined and are interacting and creating some more, let's say, smart solutions. Good, and we have many other applications. You probably know that I'm, let's say, a fan of this recommended system, not because I'm using too much, but because I'm building the technology that the recommended system are using, and also because they are a very good example of other types of models that artificial intelligence has produced in the last years, and have been very, very common used in many applications. So Netflix, but even Google is currently using, let's say, recommendation techniques in order to generate, for a given query, hyperlinks that are more relevant to you based on the analysis of the interaction that the user is having with the search engine. Or, let's say, the very popular, let's say, application Amazon that is also, let's say, using this type of technologies. Now, yeah, you know, I am a professor, I'm a teacher, so I like to teach you how it works. And I give you this very, very simple example. This is a model which is completely different from the previous one. That's to show you that there is a high variability of learning models that one can use. So in this case, if you imagine that we have this very simple situation where we have 4 potential, we have 5 movies that we would like to recommend. We know that Eric didn't like Matrix because 2 is the rating, you know, from 1 to 5. 2 is a low rating, 3 is a middle rating. The Hard is something that is a middle, but apparently is liking Forrest Gump and Wall-E. Now, what we in the sense that the recommended system can predict will be let's say, the rating that Eric will give to Titanic. So if the prediction is for a high rating, this Titanic will be recommended. If this prediction is for a low rating, this Titanic will not be recommended. Now, what we do, we typically compute the correlations of the ratings. So we compute the similarity of this Titanic movie with the other movies. For instance, we discovered that Forrest Gump and Wall-E, they are similar to Titanic just because of the ratings. So you see 1, 2, 5, 5. This is something you don't know, 3, 3. So apparently they have been appreciated in a similar way by the community. And then we generalize by saying, so if Eric liked Forrest Gump 5 and Wall-E 4, probably this Titanic will be something in the middle between 5 and 4. Okay, so you see, we try to generalize and build predictive models based on the observation that we have done. Good. So these are, in some sense, a positive example, what we have been able to do. But there are really a lot of unsolved tasks, which apparently are very simple tasks. And say what is behind this simple task that we are not able to solve is essentially the human. So understanding really humans that are behind let's say that they are from the other side of the computer is difficult. So for instance, predicting which type of holiday resort a family will book while discussing let's say the options is very, very difficult because we have to understand how people are discussing, what could be the criteria that are using in order to make a decision, and that's still difficult. Or imagine programming automatically a computer is very, very difficult. We still need programmers that are working hard in order to solve even very simple problems. Or maybe, let's say, the example of, say, supporting the sale of an insurance service and understanding which type of service a customer could like to buy. Now, I have to say that we are working on that. So we are working on problems that are related with this interaction between human and machines and try to generate solution, maybe simple solution, to this type of problem. So for instance, we have a research project on mining interaction data produced by groups. And so groups that are discussing, so we look at what they are discussing, how they discuss, and we try to make prediction about the choice that they will make. And so this is in order to understand groups while discussing issues. Or let's say the example of the programmer. We are not able to program automatically, but we are able to analyze the behavior of programmers, and we are able to understand that maybe this programmer could benefit from, let's say, using some functionalities that is not currently using, and could help him to have, let's say, a better productivity. And some other example like this, let's say, observing travelers, we can generate the predictive models of their behaviors and make recommendation to them. Now, these are examples that are using other types of, let's say, models, other type of abstractions. And I want to make this, let's say, I could not enter into the technical details, but I want to show you this, this picture just to illustrate how it could work. So here in this picture, what do you see? You see footprints of probably two animals. We have these red footprints, and then we have these green footprints. We can imagine that something happened here, and then we see these green footprints that are going here, and the red animal is not anymore there. So what we do, and what the machine is actually doing when it's looking at footprints, is trying to make guesses about what could have been happened in that situation. And our guess is that the green animal has maybe eaten the red animal, so the green animal should have a preference for the red animal. And these are the footprints that also we leave while we are visiting website, while we are using all this application, while we are living. And we leave so many of these footprints that there is a really an abundance of this data for these models in order to try to make, let's say, reasonable guess about our behaviors and try to predict our future behaviors. And this brings us to the, let's say, the critical aspects now. So these models are very powerful. They can even understand still partially what we are, what we do. And they can create also some problems. And we are aware that we live in a world of facts, of opinions, of knowledge, but sometimes we are not exchanging this information between all of us. We live in bubbles, we live in groups of people that are exchanging information among them, but we are not confronting us with the other people. And this is also because the information is obtained from this information system that are controlled by algorithms that try to give to us the information that we like and not the information that maybe could be more useful to understand the complexity of the problem. And then also there is the risk of, in this way, to treat people in a not fair way. I will discuss this after. And then there is this fear that there is this big brother that is building a world that we don't like and is controlling us, and we are losing our privacy. And I want to now, in the last 2 minutes that I have, to focus on this problem of fairness. And our models, artificial intelligence, can be really unfair. And often this unfairness is something that maybe is not really deliberately pushed into the model, but it's because even if we have a big data, many times we don't have the full picture of the situation. So look at this example. If the recommended system has not yet seen a user reading an article on the diffusion of Ebola in Africa, it will never recommend this topic. So novel topics, or topics that are not very common in the literature, and they are not common because nobody has maybe having the interest to push them, will never be recommended. So there is a tendency of this system, obviously, to focus on the most popular items. So there are technologies to combat, to tackle these problems, but we have to be aware of that. And another example I want to make, and this is just the last example, and I will stop, is really the unfairness in making decisions. Now, here, let's say maybe this graph needs some explanation. So here, this is the SAT score. So this is the SAT score is a scholastic assessment score. So what it's showing is that there is a positive correlation between the SAT score and job successful rate. So we have observed that the people that have, imagine, higher scores at school, they tend to be more successful in jobs. But there are maybe two groups of people, let's say they call the privileged group and non-privileged group. You can imagine these are whites and these are blacks. And nowadays, this is one of the, let's say, the problems that we have. And still in these two groups, there is this positive correlation, but overall, let's say the average of these scores for the privileged group is higher than the score for the unprivileged group. So if we correctly, in some sense, try to hire a person based on the SAT score, we'll end up to hire essentially white people. And this is one of the most, let's say, popular situations of unfairness. So using some criteria that are actually good criteria, but they are distributed in different ways in different groups. And we have to obviously cope with these problems, and there is research on that, so it's not a negative or negative aspect. We'll close just with one slide. If you are interested in these topics, if you are concerned about these problems, I really strongly you to look at this Digital Humanism Manifest. Here you find the hyperlink. This is an initiative that was started 1 year ago in Technical University of Vienna by Hannes Berner, and really the focus in on, let's say, understanding the impact of these digital technologies, understanding what we should do in order also to control the potential negative aspects and regulate that. And this is the end of my talk. I really thank you for the attention. Hope that you got something from this presentation. Thank you.
Francesco, thank you very much for your, your consistency, because it was very difficult to make this journey through the basics and the opportunities and future. So thank you very much. We have a question. I'd like to unmute Andrea's microphone. So Andrea, if you want, you can talk directly and read your question. Okay, you're allowed to talk, I hope. Curious. Okay. Andrea, 3, 2.
It's muted.
It's muted.
No, he's allowed to talk.
Is it working now?
Yeah.
Okay, fantastic. Thank you very much for this presentation. It was really interesting. And one of my questions during your talk was about the unsolved problems, and I was wondering whether, in your opinion, these problems are still unsolved because it is hard to come up with architectures that can generalize over these problems, or rather because, or maybe these are not either or, it's an and, or because we cannot still find a good way to represent the data that we're dealing with. So we cannot find the features, for example, that can represent such difficult matters such as human decisions, because there are too many variables, for example.
I think that there are both problems are there. So for instance, imagine the importance of context in a decision. So when you decide where to go for a holidays, you take into account, for instance, contextual conditions, so political conditions, health conditions, or weather conditions. Just to make the example simple. Normally you take the weather condition as the most important thing. You want to go to beach and you want the sun. Nowadays, maybe this is not the most important thing. You have to take into account the health conditions. And you are clever in switching between these conditions when you take decisions. Machines are much more, let's say, limited in that sense. So they're more constrained. So you give them some ideas, some model, and they tend to use the model. But switching from one, let's say, representation to another representation based on this change in the condition is something which. So context-aware systems are developed, but such dynamic context-aware systems are not as difficult to build. And most of the human, let's say, decision-making problems are really a lot, just to make the example of context, are context dependent. So capturing the exact context, which is irrelevant for that particular situation, could be very, very difficult. And also because there are many contextual conditions that are even not influential, but we tend to take into account these conditions. So there are the biases, even understanding how the people are wrong when they make decisions is something which is still difficult, because even researchers on human decision making have difficulties understanding why we have this type of behaviors.
Yeah. So once again, this is not a computational problem. It's more of a human problem, because we cannot find all the right information and the contextual information. So suppose we have all this information and we can describe it, we would have the technology to solve this problem.
But I think there is also a computational problem, because you cannot imagine that if you have the full knowledge, you could do that on the machine. So there are limitations that on the computation that you can do. So even though we had, imagine we have perfect knowledge and we have all the possible data, still this would be complex to be implemented in the machine. So there are computational aspects, so how to really perform this type of. And then obviously there is the understanding of what is important, and these representational aspects that are complex, because we don't understand completely even the problem. And then, so it's something that has very different, let's say, dimensions of complexity. It's not easy to say that's the problem.
Okay.
Thank you very much.
Thank you, Andrea. Thank you, Francesco.
Tommaso, I have a question for Francesco, a very short one.
Okay, we have 2 more, so yeah.
Okay, sorry.
Please.
Yeah, I just want to ask, the case of China, the social credit system, do you think it is a case of unfairness?
The case of China, sorry, that?
The social credit system, do you know it? I can. It's a system, a pilot system starting in 2009, in which through big data analysis and facial recognition, they developing a social credit system in which people.
Okay. I heard about that. So the people essentially control, and are in some sense they gain points when they do something good, they lose points.
Exactly.
Okay, but I mean, this is not really a problem of artificial intelligence. You know, this is the problem of people that are going to implement such a. So behind that, obviously, technology can support the implementation. No, so obviously, if you do not have face recognition, you cannot track people that are moving on the street. So you need the technologies in order to implement that, but you really need some bad ideas in your head. Because not whatever is possible should be implemented. I would say that giving some credit for good things could even be a good idea, no? But punishing people when they do some mistakes in the way that the China model is working obviously poses some problems that are also cultural problems. Here will never be accepted. But anyway, I would say that it's not a technical issue. Here is really what people decide to consider as acceptable application of technology. And now this brings us to the digital humanism. We have to obviously discuss about that, because it's something that this is a clear, let's say, case. Now we don't want this, but there are some other cases that are not clear. They're not black and white. There's something in the gray area, where it's more difficult to understand that this is good or it's bad. No? Now think about the discussion about now the people tracking for the, let's say, the control of the diffusion of the coronavirus. There is a good motivation, but you well know that behind this good motivation, there are technologies that also could support, let's say, social tracking and control, but there are some technology that will not support that, but still will give to the community the benefit of tracking the diffusion of the coronavirus. And then you have to understand the technology, the pros and cons, and then you have to enter into more sophisticated analysis, and this is a gray area.
Yeah, thank you very much. This brings us to the urgency of putting humanities in this debate, I think. So yeah, it's correct to name the digital humanism, and because if we just take this as an issue, a technical issue, the real purpose, that is politic and that is very, very human up to now, remains hidden. So this is very dangerous. Okay, I'd like to read 2 more questions. So one is in the chat, coming from Hamid Reza. It also can say that some essential problem side effects of using AI come from problem and issues in human who use AI or provide data to AI. Yeah, this is the question we are exploring. And so I add also a question coming from Francesco. Can we program AI which will systematically fight cognitive biases?
Yeah, yeah, this is something that we are trying to do now. So we recognize some cognitive biases. For instance, in decision making, there are some biases that are normally well known. And the problem is that we can even say to the person, look, this is a mistake. If you choose this, you will make a mistake. But the user has to understand that, has to trust you. So it's not, let's say, the point is that even if you have the truth, convincing somebody that this is the truth is not easy. And then there is the way of, let's say, the problem of persuading people, because that's even the situation that we have in everyday life. So imagine that someone has the solution for coronavirus, the perfect solution for limiting the number of, let's say, the spread of the disease and having the best possible situation. But then you have to convince the community that this is the solution. And this is not easy, no? So, and that's also the problem with recommender system. We discussed this. So one thing is making recommendation correct. Another is convince the user that this is a correct recommendation.
Yeah, this is a difficult balance also in the nudge theory, you know. So
yeah.
How am I manipulating or just pushing people in committing something right? What is
Technically
right?
speaking, we discussed this in terms of expected utility and experience utility. So when you evaluate an option, you compute, you as a human, you compute this expected utility. So you project into this option and you imagine what could be the consequences. And this is based on reflections, based on what you've learned. So, and this is based on what you remember about the options. But when you use this option, imagine you buy a car and then you start using the car, then it's different. Then the experience utility may be different from what you expected. And then there is, let's say, disappointment, and then there is regret. And this is something that we normally observe.
Yeah, thank you very much. Just the last question. So it's not really a question from Lavinia. I don't quite understand how you can be sure of a decision being right or wrong. Yeah, this is the point. In a vast number of cases, like most of everyday life, and furthermore, aren't our cognitive biases simply human features? So what would be the implications of getting rid of them? How can we get rid of them?
Okay, yeah, obviously, say what is right and what is wrong depends on the criteria. So I'm saying that imagine that you have the knowledge of what is good and what is better for a person. So imagine, this is something that we mathematicians, we always say. Now, imagine that somebody knows this, then maybe the user will still not understand. But obviously, your point of view is that it's not easy to say what is good and bad, because typically people are so complex that when they have to decide what is good and bad, they have so many criteria, and what maybe one day seems the good decision, the day after could be the bad decision. And that's what is normally happening. And this is the instability of our, let's say, evaluations. And then imagine interacting with humans, with the computers, and computers that have to understand this type of behavior. This is very, very complex. But this is the real scientific challenge that is in front of us. If we want really to build userful agents that will be able to interact with us, we have to understand how we behave, what are our, let's say, capabilities, and then reflect on what could be a nice, let's say, match into the computer, because not everything has to be, let's say, reflected into the computer.
Yes, thank you very much. Hamid Reza just is adding that what if people do not want to obey full to that system, so the China system, the threatening. So if you don't obey, it's a kind of new slavery, because you will lose access to basic services.
Yeah, I know.
Yeah, sure. Yeah, it's a balance. Thank you very much. So I'd like to give the stage, this virtual stage, to Dino Maurizio, and we are going to explore activities made by Informatici Senza Frontiere, and for sure we are going to taste some pieces of future thanks to these activities. So Dino, please, if you want, Dino is hidden not for some reason, but for technical problems. So you're going to share your presentation, so we will see you through your presentation.
Okay, Tommaso, you have to give me the possibility to share the screen.
Okay, yeah, I think you can, because you are...
No, he said that host is disabled.
Okay, co-host, you are now co-host. I thought I had already made this. Okay, are you able now?
That's the...
Okay, now I see the debate is evolving in chat. Thank you very much.
You see?
Not yet.
Not yet.
Wait a second.
Wait a second.
Here it is. We have your screen.
Okay. Okay. So, good evening to everybody, and thanks for the invitation. Let's start 1 second just to describe my organization, that is Informatici Senza Frontiere, that is an Italian NGO that use the ICT competences to help people and communities living in poor or difficult socio-economic situation. That means that in few words that we are trying to help in overcoming the digital divide of the communities. And we work in Italy as well as in the developing countries. By the way, I invite you to go to this the website that is www.informaticisenza-frontiere without any .org. In my speech, I'll try to give you some disordered thoughts regarding the intelligence that is inside the computers. And I will start with the traditional ICT. As you can know, the traditional ICT comes from the logic of Aristotle, that with his syllogism give us the possibility to start from premises and go to conclusions, following a series of logical steps, and going from one step to the other, you can go to a right conclusion. Of course, Bull give also his view regarding the logic, and you have other contribution to arrive to the electric circuit that realize the thinking, the reasoning. And the traditional ICT is based on the limited amount of data and use finite algorithms. So everything is defined. You can go from A to B only and following a series of defined steps. And if you follow the steps, you don't have any, you don't make any mistakes. All our realization that we have so far in the world, most of them, of course, are made by with this kind of ICT. And I give you an example what my organization did with this kind of ICT. But before showing a video that illustrates the project, I have to tell you a story. And this is a story of Vincenzo. Vincenzo is a trumpet player. He plays trumpet and he writes also music. He's quite famous in Italy. He plays mainly jazz and also some modern music. He is so clever that he has been invited by the Lucio Dalla, and he played with Lucio Dalla. He also invited to play in the Blue Note of New York, that is the temple of the jazz. And so his life is, of course, music. And he play, and as I said, he play and compose music. But one night, coming back from a concert, driving his car, another car crossed his way, and it happened a terrible accident. After that, and after 1 week of coma, Vincenzo waked up completely paralyzed. Vincenzo now is able to move his face, is able to, fortunately, to speak, but any other part of the body, of his body is blocked. The only thing that he can do is is able to move just a bit his left arm, and with this movement he can move and his electric wheelchair. We met Vincenzo after 7 years of this accident, and still his dream was to play his trumpet, because at the time of the accident, as you can imagine, all the life of Vincenzo was in some way destroyed. We met him even with this dream, and we put in place a small team of people, and we work on the possibility to give him the possibility to play again his trumpet. We put some electromagnet over the piston of the trumpet. We connected the electromagnets to a microprocessor, and as well we connected a sort of joystick to the microprocessors. And we make a correspondence between each position of the joystick to a position of the piston. And here is the result. And by the way, Vincenzo now is playing in concert. So I stopped but you can imagine, I hope you have seen how it works. So with the traditional ICT, you can do a lot of things. You can do the traditional elaboration, if you want, of data, but you can do also something different, like this project demonstrates. Going to artificial intelligence, we have a different approach, you know. We start from data, and data is just a series of 0 and 1, so there is no meaning in that. But from the data, we can get information using algorithm or analytics. And then, in such a way, we got information. So it means data with some meaning. And then, other step, we can use and apply some machine learning mechanism to build the knowledge that usually human have it using the experience. Here, the experience has to be realized through the machine learning mechanism. This is a different intelligence, because if the first one was a deductive reasoning, this is an inductive reasoning, because we start from and we apply to data some probabilistic algorithms. And I think that this is another important element that we have to take into consideration when we think about the future, because also in the future we will have the traditional ICT and this kind of ICT. I skip this chart that is an example similar to the one presented by Francesco, that they show a correlation or not correlation between the divorce rate and the per capita consumption of margarine. And here you can see some example of IA. Example that are used in the developing, or can be used in the developing countries. As an example, in Uganda, there is a IA application that starts from the image of the cassava plant. The cassava is a sort of corn, if you want, and then it is a base of the food of the population. And through an IA application, they can see if the cassava has some disease. And in addition to that, there is also a GPS mechanism that gives the possibility to map the disease in the territory. Other application very useful is a digital stethoscope, because with the digital stethoscope, not only you can apply it to make some diagnosis far from the patient, but also because there is again an artificial intelligence application that gives the possibility to make a sort of diagnosis and maybe a bit of therapy for the patient. I underline also that in the last weeks, we had also robots working in Rwanda to assist the coronavirus patients. Then another thoughts that could be useful is to think about some experiment that has been done with a real neuron. And it is an experiment done in UK, in the University of Reading. And it works in this way. They build a small car, if you want, a small box that could move because it has a couple of wheels. And this box has also some proximity sensors that are able to understand or to see when the machine, this little car, go close to an obstacle. So they build the machine. They put a layer of neurons of rat. I think, if I remember well, they use 7 neurons that they keep alive in a physiological bath. And these neurons are directly connected to the electronic part of the machine. There is no learning mechanism, no artificial learning mechanism in this machine. And I show you what happens at the beginning. The video is not so clear, but you can see that the machine moves randomly, and sometimes going randomly, they go and stop near the obstacle that in this case is a wall that is around the table. And so in that case, a human move the machine out of the wall, and the machine start again to move randomly. After some hours of learning, if I can say learning, this is the result. The machine learned by itself to avoid the walls. And so this is another example of artificial intelligence that use, in this case, the intelligence coming from the neurons. So we start from the logic. We add silicon to the logic to have the first computer and the first kind of intelligence that we have in the computer. Francesco talked about AI and about the cognitive and maybe neuromorphic computing that are in developing form in these days. I add this biological artificial intelligence brain with some thought about it, and think also to someone that says that by 2045 we will reach the singularity. What is the singularity? The singularity is the time when the intelligence of the machine will be superior to the intelligence of human. This is among the people that thinks about the singularity is the most famous is Kurzweil. That is, I think that is a genius, even a bit crazy, of ICT, that it has, I think that it has more or less 70 years. Is it 70 years old? And it is a man that take 150 pills a day in order to arrive to the 2045 still alive. So I hope to give you some idea on what could be the future, how can be the future in the ICT area. And I didn't talk about, of course, imagination, awareness, emotion, consciousness, that is overall, that is another interesting story regarding the future of ICT. So I finished.
Dino, thank you very much for your impressions about future. Also, all the examples you made for me was very interesting. For example, the layer, the neuronal layer. And if I can make your question, so please, everybody is allowed to write down in the chat or both in the Q&A part section. So we were talking briefly before about purpose. So, okay, I'm visible now, sorry. About purpose. So you showed us a kind of neuro robot. I don't know how to define, if we can and if we have to define that kind of thing. And so you express also the difficulty to say it like learning. So if it was a learning, what I asked to myself and to you is what was the purpose of the training? So because you told us it was training in some way. So with what purpose? Because you said before that no kind of impulse, no kind of task was given. Am I correct?
Yeah. They they put the connection between the if you want the sensor or to the command or the command for the wheel in contact with the neurons. And so the neurons understand at the end what they have to do. Instead of going randomly, they understand how to manage the this little dispositive. The purpose is just a purpose of a study purpose, I mean, but you can also think about the possibility to use this form of intelligence, if you want, to help people that doesn't have all the human neurons working properly. Because you can, if you want, try to substitute neurons with other neurons that are associated to some specific task. That could be the movement of the arm, as an example. Or on the other hand, you can also think about machine that can be trained in a different way to do some specific task. Instead of using the artificial neural network, you can also use a sort of real network and see if you have some advantage.
Yeah, it's very interesting. I want to tell you that if you want to make a question, you can raise your hand. So I think you have a button there very close to the chat, thanks to which you can raise your hand and I'll allow you to talk directly to panelists. So thank you for your presentation. I think it's very good to have this kind of scientific base to understand and to overcome also some biases and prejudices we suffer naturally. Okay, and I'd like to connect the digital humanism and okay, I'm coming, and you know, this evolution of robotics, because I was thinking about Derek de Kerkhove, and he's a person, a human, probably Federico Bomba knows him better than me, and but he foresee a new generation of humanity and biological mechanisms, and he foresee an evolution for us. And so I think how we can make the manifesto concrete, also thanks to this kind of projects, because behind the project like yours, Dino, you have to have a very precise politics. So a very intense impulse to implement that kind of activity. And so this is my reflection. So this connection between a vision of the political manifesto, the behaviors and the attitudes politicians now have, so very ignorant about this, even if we have a lot of commissions in Europe. We had a lot of very interesting white papers, and not only white papers, talking about artificial intelligence and the perspectives, and an activity like yours. So how to make massive this kind of projects. Okay, I read also this question, this idea coming from Amidreza. Idea, then connect all neuron robots, rats, wirelessly, and leave them in city to work with each other and find problems in the city. For example, it identifies smelly garbage. So finally, useful rats. Even if everything is useful, everything is very connected.
Yeah, I think that the example of the real neuron is a bit curious, so it is quite interesting. Maybe is also the less practical, at least now. But I think that going to the use of the this intelligence, I would say intelligence in general, not only artificial intelligence, but intelligence. I think that is one of the key questions for the next future, because we are still, I think, it is my opinion, we are often, we risk at least to lose the control of what we are doing. Because sometimes we even are not able to understand why the machine arrives at a certain decision. And so we have to trust or not. And we trust or not, it is a big question mark. You have seen it in the as an example, the autonomous car, but there is the same question. You can use it when a machine gives you a suggestion for a treatment of a patient, as an example. This is the first, from my point of view, the first problem that we have to take into consideration. The other problem is I mean, how we use this intelligence. Are we using this intelligence for helping people, or are we using this intelligence for making money, as an example, or for bad things, for controlling people, as an example. This is another question that you can apply also to the traditional, of course, ICT. But in the future, being more and more ICT, being more and more power in the ICT, it will be a big question that we have to think about.
Yeah, thank you very much. It's a very important passage. I take what Rosella is saying because she asked us, what are you going to do with the results of your survey? Thank you for this question. It's very important to understand. I'm sorry because I didn't make it transparent since the beginning. So we'd like to use this kind of data to make a debate. Basically, we are doing this web talk with the same intent, with the same purpose. This is the point. In the first web talk, we asked to participants what they thought intelligence was and artificial. So what kind of artificial intelligence they were using. And the question we made today, so what kind of future do you imagine? We want to create a debate in the city of Bolzano because our project with IAQOS wants to be implemented in Bolzano. But our little artificial intelligence won't solve problems. Its first issue, its first purpose, speaking about purpose, is mainly to make transparent the debate. And so all these kind of answers will be debated, will be evolved and probably operated as you are writing down in the chat. And so, okay, just to be clear, it was not meant as criticism, but as a point related to how AI decisions are taken, making them transparent. Yeah, I think it's very important. So the project of IAQOS is the use of artificial intelligence and the development, the training, all the process to have to reach this goal of having an artificial intelligence. But what interests mainly for us is, the process. So how we are making a public debate about data, about values, about what you think is important for the city. So, it is really a tool, a good tool to leverage this debate and this critics, because, value also what Lavinia told us before. So what is wrong, what is good, what is bad, Francesco also told us, is a human question. It depends on the task. So it depends on what are the pillars of the artificial intelligence or the process you are implementing. So thank you for writing down this fact of transparency. It is very important. Yeah, also Antonella agrees. Okay, I think we, if you have any other question, please feel free to write down. We have this great occasion to ask a lot of difficult questions. I wrote down a lot of points here. For example, Morozov, Eugene Morozov, sociologist, he writes down about big properties. So I guess, the fuel of the system, of this ICT system are data. And so what I asked myself is, okay, what kind of data? And most of all, who is able to operate this data? And so for me is important. And this is a question I like to give to Francesco and to Dino also. This is a question of properties. So during this pandemic, we saw just 5 or 6 big companies taking advantages in collecting and elaborating strategies on data. So about recommender system. So few people, few organizations are now very able to understand our behavior and to manipulate or to convince in acquiring some services or goods. So what do you think about this fact about properties? So because nowadays the system is failing is the first quotation of the Digital Humanism Manifesto. So okay, this system is failing, but is connected with this data property.
If you want to know my opinion, obviously, so we suffer a lot from this. So even the research now is not able to progress as we would like because we don't have access to certain type of data. So for instance, here, if we talk about this recommended system or supported decision making, you cannot elaborate too much, or you cannot go too far if you do not have access to this type of information. So examples of interactions of user with applications, or let's say behavioral tracks. Sometimes you have this, but most of the time you have to generate yourself the data, and typically are in the size which is not comparable with the data that the big players can have. And this makes really the things very, very difficult to be developed. A lot of research nowadays, I would say, is limited by this factor. But even in the healthcare, for instance, so I mentioned the fact of this automatic diagnosis. It's not true that we have access to a lot of information, for instance, images about cancer patients. That is because of privacy reasons. So there is also, here is not the problem of maybe who is exploiting this, but also because we are reluctant to give, say, this data available for the analysis. So there are several considerations that we have to make, and we have to discuss this. But for sure, big players, they have access to large repository of data that they can exploit, and we, I say we in the sense of the researchers, but obviously even the citizens that do not have access to that information cannot progress in that.
Thank you very much, Francesco. Dino, if you want to add something.
No, the property of data is one of the biggest debate now, and there is no solution because it is quite difficult to limit the use of data and to limit the or better or not limit the diffusion of data because there is no legislation. That is, and by the way, if a legislation must be, it should be a worldwide legislation that take into consideration every countries. And if we are not able to have legislation regarding, as an example, the nuclear bomb, or the diffusion of let's say the data related to the COVID, it will be even more difficult to go in this direction in the future. On the other hand, the globalization is going helping the use of even more and more data, and only few, as you said, only few companies and only few organizations has the power to have the data and to manage the data.
Yeah, thank you very much. Yes, yeah, we have some some envisioning of this kind of future now during this pandemic. Our democratic organization, for example, the OMS, the Health World Organization or European Commission, they shrink their power, and people is more, how to say, is more happy to use something private, some private system, instead of believing in having, you know, trust in some democratic organization. And I just want to add, before going to, I think, the last question by an anonymous, our project with IAQOS in Bolzano is specifically this. So just to make a democratic, you know, carpet of data, thanks to which everyone will be able to make his own thoughts or extension of the tool. So it is very important to understand this. IAQOS is the acronym of Intelligenza Artificiale di Quartiere Open Source. So it's an open source district artificial intelligence. We want to try this, so to open the argumentation. Okay, the anonymous. In creating, I think this is mostly for Dino, in creating an AI based on biological components, like the robot with neural cells of a rat, at what point can we call it an android? Is a future where humans are helped by such androids possible? And if so, at what point can we discern what is android and what is human?
Is this question for Kurzweil, I think, not for me, because he trusts this mix of human and machine in order to say that for 2045 we will have a better life where we can decide the lengthness of our life. But I think that it is too much in the future to have a clear view on that. I hope that there is another question that, by the way, that I read that say that ask if I will trust human or not. I think that the key point is to be in control of what we are doing. And we must be in control of the artificial artifact that we do. We should put some key element in the building of this artifact that give us the possibility to control the artifacts. Otherwise, if we don't know what they do, we are not able even to understand if they, as an example, will trust us or if they are doing something for a reason that we don't know. So this is quite important to understand that.
Oh yeah, for sure. Yeah, so is telling us, Amidreza, we should always be careful that AI be in our control.
Must be.
Yeah, I think so.
Otherwise, we have to decide not to build a new machine.
Yeah,
I prefer to have not do with something that I don't control.
Yes, yeah. Sebastian Cavada asks, maybe this is a very broad question, okay, we are ready, but do you think that if and when we will reach the singularity, would it be before or after we have discovered how our own brain works in details, or will it be the opposite, or maybe something in the middle, more like parallel and intrinsic research?
Oh, my personal opinion is that we will not reach the singularity. So I think that we will have many new machines, if you want, that are built looking or trying to imitate our brain. This, of course, we will have. I see the knowledge even in our brain that is so far from knowing how it works that we will have tens of years in front of us before we reach some kind of deep knowledge of that. I don't know, Francesco, if he thinks something different.
No, I'm not an expert in hardware, so I don't know what is the best, let's say, what could be the future type of computer. Obviously, there are a lot of people that are trying to build computers that are working in a completely different way from the way the computers are now working. So that could open, obviously, certain possibility. Think about now this image recognition activities are supported by this GPU that were not available a few years ago, and in the future there will be other technologies that will support, say, our typical computations or different computations. But say, so in that sense, I say I really don't know, but I think that one say point that we should discuss, and I think it's very important, it's really what is the criteria that we are trying to improve. Because so far, most of the research, and this is an important problem, even in computer science, is focused on efficiency. So all the mechanism, all the computations that we have done have been tested towards, let's say, being efficient. So how to solve this problem in a more efficient way, in a more effective way, in less time. But maybe we forgot to consider some other properties and that are also important. So, and this is let's say, the generality of the solutions, and sometimes the resilience of the solution. So are we building solutions that are resilient in an environment that are not only fast, but they can also react in the proper way? It cannot really collapse when some conditions are then not met. And this is something that we are now experiencing in this crisis, and let's say in this period of crisis. So that the usual ways of, let's say, performing our activities, even economic activity, was mostly focused on this efficiency. And now that something unexpected arrived, we are not able to do anymore, and then we are losing. And that's because maybe we have built a system which is too much focused on certain type of solution. This is a more, let's say, general discussion, but could be relevant for artificial intelligence as well, because artificial intelligence techniques have been tried essentially to solve the task in a more effective way. But they have not really, say, apart from a few of them, they have not worked on trying to get more robust solutions that will work even in unexpected situations, and will also maybe evolve in a way that can bring more diversity and more, even at the end, more democracy, because this is what we expect to have, not to enter into this funnel of let's say small number of possibility, but to open let's say the funnel in the other direction and to look at the full set of possibilities. And this is a completely different ways also of doing research.
Thank you very much about this. Federico is answering to Lavinia and showing the biases that the fact of a lot of scientists are men. So, sorry. Oh, okay. Was for everyone. Yeah, but I think he's correct, nevertheless. Okay. I think we can stop here. Thank you for this very enriching debate. And for sure, we're going to use all this information, the results of the surveys, to compose a very aware team for our campus in the next months. So I'd like, in giving you the announcement of the next web talk with Antonella De Angeli and Riccardo Coluccini about biases. So we are going through this this theme we approached already about biases and where data come from. Just saying hello